Hello, viewers, listeners. Thank you for joining us today for another episode of the Amazing Podcast. And we talk about all things Kubernetes and cloud native here. If you like what you listen on this podcast, definitely go to our website, amazic.com, amazic.com. We cover a lot of similar topics like this, where I write, a whole bunch of other writers post content. There's event coverage and there are job listings. So there's a lot for you to see if you like this. So definitely head over to the Amazic website. I'm Twain Taylor, editor at Amazic. And I have with me today Natan Yellin, who is the CEO of Robusta. And their website is robusta.dev. Robusta is product in the observability space. Kubernetes observability is what they specialize in. And that's what we're going to be digging into today with Natan. Natan, it's great to have you with us today. Thanks for joining. How are you doing?
Doing good. It's a pleasure to be here.
All right. Awesome. So if you can tell us, Natan, a bit about yourself and your background and what led you to start Robusta.
So it all started, I suppose, when I got a computer at age 14, and my mom was convinced I should go outside more, and that nothing would ever come of me spending that much time in front of a screen. But if you fast forward almost 2 decades, she actually recently told me that she thought all that time paid off and it was a good investment. So if you look though at everything, and everything in my life has almost led up to this point, I got started as a developer, started programming at a young age, and I was involved in, I've kind of always been somewhere between that, between DevOps, what was later called DevOps, or platform engineering and development. So I come from, on the one hand, from like a real development background, but I was always the first person at companies I worked at to like set up the Jenkins instance, and the person to be kind of setting up the DevOps workflows. And before there were even containers, doing stuff with like build environments and truths and setting up what now we would really call DevOps and CI/CD. And it's been a really interesting journey because the industry has really changed in how we act and how we work, and like in terms of who's doing what in the different companies. And one of the confusing things, if you look at DevOps and platform engineering and SRE and all the other buzzwords out there, very often people will describe the same thing using 2 different buzzwords and have an argument about which way is the way to do it, but they're actually describing the exact same thing. So wherever you called it though, there's been almost 2 big shifts that have happened in the industry. The first shift was moving away from dedicated operations. And what I mean by that is, once upon a time, you developed software, and when you took that software, then you give it to someone else, and he installed it in a different place, and he operated it, and he'd come back to you once a quarter and complain about problems, right? And that was you build it, you hand it to someone else, and that other person goes and runs it, and he does that model. And this famously, Warner Vogel from AWS said, this is build it, throw it over the wall to someone else, and he takes it. That's that model, whatever you call it. I'm not even going to the semantics, right? And then there was this movement, and this was often called the DevOps movement, that said, no, this way of doing it is awful. There's no accountability. The person who's running it doesn't actually know the code, and the person who knows the code doesn't actually know how it's being run. This was bad. We're going to do something very, very different. And the first way that people thought to do something very different was to say, okay, you build it, you run it, and you do everything. So like the developer, he's going to do everything from, and DevOps, as it was originally imagined, was developers doing apps. So it was this thing where like every team will do both the development and the operation. And over time, whatever you call it, I'm not like, I don't want to get too much into the terminology because we can argue about terminology, but actually agree on what we're actually describing. Emerged this way of thinking where we realize, okay, developers are not going to know everything. Actually, there is a whole discipline called operations. Actually, we're not going to expect the Java developer to also know about all the Kubernetes stuff, all the production, the nodes, the virtual machines, the financial planning for cost and like the FinOps, all the stuff around reliability and SREs and SLOs, there's actually a whole lot of stuff here that's a real discipline. It's a real job. Like maybe we were a little bit too fast to say, oh, that person doesn't have a job anymore. Now the developers are going to do it all. And we'll just do DevOps. And over time, we realize that this is actually a little bit of a different way of thinking and operating than what we originally called DevOps. And now this gets the name platform engineering. And there were other adventures along the way, like kind of SRE, which is saying, okay, we are going to have a dedicated ops guy. And there were all these other things. And again, some people will take a bone to pick with like what I'm describing, saying, no, that's not DevOps, that's this, or that's not platform engineering, and that's actually this. I don't want to get too much into the terminology. But the broad way of thinking of it is that there have been these three modes that we have experienced as an industry. The first mode was developers doing zero ops. The second mode was, at least we claimed or we thought, maybe developers would do all the ops. And now the third mode is this shared responsibility model where developers have ownership, but there are also other people involved who have domain-specific expertise around operations. And the reason why I'm giving all this in an intro, back to your question about who am I and what do I do and how did I get into all this? Well, I've kind of seen a lot of this along my own journey. And then most recently in the Kubernetes space, this problem became even worse because in the Kubernetes space, like that model, developers do everything. It just broke so catastrophically and so horribly because everything became very, very big. And I actually love Kubernetes. I think Kubernetes is fantastic. I think it means that you can run the same software without having tie-in for a specific cloud. I think it means that every company can provide Google level infrastructure and provide high availability and can have health checks and can do like multi-AZ stuff. I think Kubernetes is fantastic because it makes available to every single company what was only available previously to a small number of companies. But it does mean that the operational complexity goes up and you can no longer expect developers to know all of that in addition to all their regular responsibilities. It's just not realistic. If you look at the best companies, you look at Slack and what they do and how they operate, you look at Spotify and how they operate, you look at the best companies, no one is operating on this developers do everything model. And what's emerged is this platform engineering model. And again, people were really doing it before we even called it platform engineering. But that's the buzzword. So we'll go with the buzzword, platform engineering. And what I do personally at Robusta is I'm building an observability platform. We're building an observability platform that's really optimized for the shared responsibility model. And really the only observability platform that thinks, okay, well, what is the DevOps engineer? What is the platform engineer doing? What is the developer doing? Where does each one of those people need to see? So the developer wants to see an application-centric view of the world. What does the platform engineer want to see? How do those two teams communicate with one another? What are the problems that each of them have? Not just around observability, it's even also around how do you set CPU requests and limits on Kubernetes and all that. And we're building the platform for that evolving and emerging interface between platform engineers and developers. And that's what I do. And we started the company 2 years ago. Today, we have hundreds of customers already on the platform. It's been a very wild roller coaster. And every day I'm waking up and hearing from our customers and learning more about this and kind of my own understanding of the world and of how these teams operate is evolving as well. We're learning, and it's been a very exciting adventure. And that's the long-winded answer. I'm sorry that took that was a little bit of a long answer. Wow. That's who I am, and that's what we do.
Yeah, that was quite a start. There's a lot to unpack there, and I think you have a lot to say about a lot of things. And I get the feeling this is going to be one of the really fun podcast episodes that we've ever done. Where do I start? I want to just dig in a little about your background. So did you actually do a software degree and stuff, or did you not go that route and you just learned on your own?
So I have a degree in computer science from the Technion, the Israel Institute of Technology, and I have mixed feelings. I suppose this is going to come off in most topics I talk about. I have very strong opinions, but my strong opinions are often, it's complicated. I won't say absolutely yes and absolutely no. So when it comes to software degrees, then I have strong feelings that I personally benefited a lot from that degree, but that most software engineers do not need a degree in software engineering.
All right. Wow. I like that nuanced answer. Yeah. You got us started, I think, on a good note talking about platform engineering, which really is, right now the focus of so many organizations in the space. And clearly, it's over the past 2 years, I've seen it just kind of take over conversations in this space, platform engineering. And it's really cool that you mentioned how Robusta is trying to build an optimized platform that caters to these different roles, the dev, the platform engineer, the SRE. And I want to dig into what that means more in just a bit. But before we get to talking about how Robusta solves for these challenges, I want to just define the challenges themselves. So you kind of briefly mentioned that the challenge is Kubernetes has become, Kubernetes is complex, and that creates challenges for developers and even ops folks. And so could you flesh that out a bit more? What kind of challenges are we talking about, especially in context to what we're moving towards, which is talking about Robusta? What kind of complexities do you see are the most painful ones in the Kubernetes space affecting dev and ops?
So I'll touch on 3 challenges, 2 of them around observability and monitoring, and 1 of them around cost management. And they all are about this interface between DevOps or platform engineers and developers. From now on, I'm going to only say platform engineers, but there are people who call themselves DevOps who I'm including in the category because they're operating with this platform engineering model. So
it gets really confusing. Different people's different definitions of DevOps.
You have people whose title is DevOps, but they're doing the Warner Vogel throw it over the wall model. And you have people whose title is DevOps and they're doing platform engineering. You have people whose title are developer, but they're doing the DevOps model. So it's all a mess. But back to your question, I'll speak about the first 3 challenges that every company who runs Kubernetes in production hits. Challenge number 1, you have a developer, he deploys an application to production, and something goes wrong with that application. And it's usually not clear in the first moment is an application issue or an infrastructure issue. And the simplest example of that is you deploy a pod, your pod is crashing, and you get an alert saying, like, you have partial availability or you have a crashing pod. And just to make this really clear, I will share my screen and I will show you exactly what this looks like if you use Prometheus.
Okay.
You get an alert like this. Mm-hmm. And the problem with this alert is that it isn't clear from looking at this. Is this a developer issue or is this a platform issue with infrastructure? And beyond that, you could say, okay, well, the pod is crashing, so it's got to be a developer issue. Okay, well, if that's true, well, what does the developer do based on this? Where does the developer look? And the easiest way in 60 seconds to do that triage and to determine if this alert is a developer issue or platform issues to just look at the logs for this pod, right? And you can see the logs of that pod, then in 60 seconds, you'd understand. And I'm not going to speak yet about Robusta, but that's the first challenge that we touch on is when an alert comes in, we really help you say fast, is this a developer issue or is this a platform issue? And who's the person to go? And the challenge here is that without this, then often like a developer gets this and then he opens a Jira ticket for the platform engineer and says, okay, troubleshoot this, or the platform engineer the developer doesn't even get notified, the platform engineer gets notified, and then he has to look and then tell the developer. So there are challenges around here about taking an incident or something that's going on in production and responding fast. And it can sometimes take half a day or even a week to go and investigate something like this, not because the investigation is hard, but because it's a question of ownership. And when you know, iron clear, this is my problem, I'm the person who needs to look at it, whether you're the platform engineer or whether you're the developer, you'll solve this in 5 minutes or an hour if it's complex, right? But the time is wasted on that question of responsibility, and that's the first challenge. The second challenge is you're deploying a new application, you need to set up monitoring, and there's a gap here between the people who are familiar with application, the people who really know PromQL or like know how to configure all the Datadog dashboards and stuff. And there's a gap here, and typically the platform teams have deep expertise around Prometheus and PromQL and monitoring, but they don't know the applications as well. And there's some challenges around here as well. And that's the second challenge in terms of how you set that up. And that's where our commercial offering also plays a role. And then the third challenge is how do you set requests and limits on Kubernetes for CPU and memory? And to give the background on that, then when you run an application in Kubernetes, Kubernetes makes you, or it highly recommends if you don't do it, bad things will happen, but Kubernetes makes you say in advance how much CPU and memory will your application need. And No one wants to say in advance. You want like Kubernetes to be smart and to scale automatically, but for various reasons, Kubernetes has to start from an estimate of how much memory and CPU will your pod need. And to set that number, the platform team can't set that number because they don't know your application. And the application team often doesn't really know. It's more of an operational question for them. So the way it happens, usually in most companies, is the platform team will say to the developers, set a number, and the developers say, okay, and they put in their 8 gigabytes, or they put in their 16 gigabytes because they think that'll be enough. Or they put in 3 CPUs. And there's this fantastic study from Sysdig from just about 2 months ago. And Sysdig found that those numbers are off by 69%, and they're off by 69% on the high end. And this means ultimately you end up paying for 69% more infrastructure than you need. Many people don't realize it. When you put in a number like that for your CPU request, Kubernetes actually goes and allocates the space. And you can end up having very, very low utilization, like 10%, 20% utilization in your cluster, and not actually using most of it, but you're still paying for all that space because you got those numbers wrong. So we have an open source project that helps with this. And of course, it's also part of our overall platform. And again, it comes down to this shared responsibility model between developers and platform engineers. And those are the type of problems that interest us.
Yeah, so, about the first point that you mentioned, which is a lot of time gets wasted because people are not clear who really owns an issue when an issue comes up. Do you think also tool sprawl, and even within tools, just vanity metrics, just overload of alerts and unnecessary data complicates this and makes it worse? Any comments on that? And for someone who's listening to this thinking, I've already got enough monitoring tools and I can't manage them, why do I need one more in the mix? What do you have to say about the challenge of tool sprawl and even other related issues like alert fatigue and all of these?
Yeah, it's a huge, huge problem. One, too many tools. And I know I'm talking about another tool, so there's irony there, but I'll explain why it's different. Too many tools, and then you don't know where to go and look. So you have all the data there, but you're not actually looking in the right place. If I go back to that alert, think about it. Like with that alert, then you have the right data, the logs, and like all the data is there, it's just not in your Slack message or your Microsoft Teams message. And then on the second point, then there's a big issue around alert fatigue. And I love Prometheus and I love Prometheus stack, which we actually bundle with Robusta, but out of the box, the default alerts are not good. And to give an example of that, I can tell you already, we have enough mileage with our end users who use like Prometheus stack on GCP and on AWS and OpenShift and all these other Kubernetes platforms. If you install Prometheus stack, you just install Prometheus, take the default alerts, and you install that on Google Cloud, on GCP, on GKE, the Google Kubernetes engine, then out of the box, you will have an alert on high CPU throttling on metric server, and there's nothing in the world you can even do about it, because this is a workload that's running in your cluster that Google controls. If you make changes to it to fix the problem, Google rolls back those changes. There is absolutely nothing you can do about it. But out of the box, you will have a noisy Slack channel with an alert arriving every 4 hours because of that problem. So one of the first things we did when we started building Robusta is we heavily are based on Prometheus, and we bundle Prometheus stack, and we installed Prometheus stack, and we installed Robusta on every major cloud provider that has Kubernetes, on DigitalOcean, on Civil Cloud. I guess that maybe they're even the smaller players, right? On AWS, on Azure, on whatever, right? On all the different things. And we built an Excel spreadsheet of where do we have default alerts out of the box. And then we went about really either adding like suppression rules for known false positives, or adding stuff that for each one of them explains what the issue is, or fine-tuning the alert so that it doesn't fire. So it's a big problem. And our philosophy with Robusta, and tying this back to the tool sprawl, is we will take your existing tools and make them better. We will not ask you to replace anything else. We're 100% value add on top of Prometheus, and we take the alerts and we make them better. And we pull in data from other tools, but you're not going to feel that there's like one more place to go and check stuff, the opposite.
Interesting. And, just related to this as well, so each of these observability tools, they have different schema, different metrics, just a different way of using them, different purposes for each of them. And considering Robusta integrates with many of them, what are some of the design decisions you had to make along the way when building Robusta? And how have you had to build Robusta in a way that it brings out the best of each of these observability tools and puts them in a consumable and a well-designed package that could be really useful and really practical for your customers?
So can I answer the question by walking through an example? So let me go back. I'm going to share my screen, and I want to focus on this Prometheus alert. And everything I'm going to show you is 100% open source and free. We have a commercial offering. It doesn't have to do with what I'm going to show you right now. So everything I'm describing is 100%.
What's the name of the open source tool?
Robusta. So you would go get
the same.
Robusta. Yeah.
Okay.
Okay. So if I start here, you have this Prometheus alert. And the first thing that you want to do as a developer or as a platform engineer, you want to see the logs that's related to this. So instead of having Prometheus send alerts directly to Slack or to Microsoft Teams, you send Prometheus alerts to Robusta, which runs inside your cluster. And it takes that alert and it just pulls in the right context. So now this alert has pod logs. Same exact Prometheus alert, QPod crash looping, container crash pod, right? We have all the data here, and we pulled in the data that you need to see. And there are many examples like this. Like if you have a pod that gets out of memory killed, we will pull in the graph of the memory usage. We pulled in exactly what you need to see. If you have an issue with like your Prometheus, it's firing like a problem evaluating Prometheus rules, we'll pull in data from Prometheus and we'll show you exactly which Prometheus rules have a problem. So what we do here is we're taking like different observability sources and we're pulling them all together into one consumable unit that's related to one another. So here we have the Prometheus alert, but we also have logs, like what you would get if you were in kubectl logs on the right path. So that's our philosophy. All the data is there, but the right person isn't seeing the right data at the right time. And how do we fix that? And then in terms of design decisions, this is actually behind this simple looking thing, there are actually some complex design decisions. When I say Prometheus, some people hear Victoria metrics, some people hear Google managed Prometheus, some people hear Azure managed Prometheus, some people hear CoreLogic's Prometheus, and supporting this really simple thing for all those different installs and for everyone in the industry who has something Prometheus-like is actually non-trivial, but we made the decision that we're going to do it. And it's a decision we've revisited a number of times and we discussed internally, and we decided ultimately that it's the right path for us. But to do this in a way that supports all the different things is not so simple. Everyone is supposed to be Prometheus compatible, but I can tell you that there are actually various APIs that are only implemented by Prometheus itself and not by the other providers. So it's not always so simple, but that's a design decision that we made, that we will make our common denominator, or at least common denominator for who we support, everyone who's using Kubernetes and everyone who has something that's Prometheus-like, and we will give all those people better alerts, and we would do that in a pure open source offering. And that was kind of the guiding principle for us. And from there, then you derive a lot of other stuff and everything else follows.
Mm-hmm. Okay, wow, that's a good example. So when you say integrating with Datadog, even there, are you talking about the Prometheus metrics within Datadog is what you refer to, or do you mean Datadog's metrics apart from Prometheus as well?
So we have some direct Datadog integrations today, and especially where we can send data to people using Datadog. If you want to consume various things that we produce that Datadog itself can't produce. And we don't right now in the open source heavily target Datadog and say we're going to make Datadog better, give better Datadog alerts. We don't do that today. Something we get asked to do from time to time. But today we don't focus on that. We're very, very focused on Prometheus users and the Prometheus community in all the different forms that is.
All right. Cool. Yeah, so if you could show us the product itself, a walkthrough would be really great to see.
Yeah, absolutely. So I'll take you through it, how someone experiences it typically in the product or in their user journey. You start with the open source, and you have here an alert that you get better alerts. You can click investigate. That would take you to our SaaS platform, which I'll show you soon. You can click silence. That's an easy way to silence the alert. It'll take you to a page where you can configure the silences. So Prometheus, take Alert Manager, take what's already there, make it more accessible, right? People will silence stuff if you give them a button to do it in Slack in the right context. If they have to now go to some other place, they won't always do it. And just for what we do here is not just like pulling in logs for a crashing pod, like here's something that got out of memory killed, and we pull in data here about the memory usage. here's a Kubernetes job that got stuck, and we pull in data on why the job is stuck and what's going on with it. And this we do in the open source. And on the open source, we take this data and we send it to a whole bunch of different locations. So we can send data to Slack, Microsoft Teams, Datadog, Discord, Telegram, Mattermost, Ops Genie, PagerDuty. You can open Jira tickets. You can send the Yandex Messenger, Victor Apps, right? Cisco WebEx to all these different destinations. Here's what it looks like if you open the Jira ticket from a Prometheus alert. And again, with all the enriched data. So here's a different example. There's this alert called Cube Memory Overcommit. And most people who see that alert don't know what it is or how to fix it. And we pull in all the data you need. So currently the total of your pods is 1.93. Total allocable memory is 3.68. And the cluster is currently okay. But if a single node fails, then some pods won't be schedulable. And here's how you fix that. So really trying to take alerts and turn them into something that's actionable. And all of that is the open source. And then we have a SaaS platform, and that's what you see over here. And this is one single pane of glass for everything that's going on in your cluster. And this is built also with great support for not only single cluster environments, but multi-tenant environments. People run multiple copies of the same application, either in multiple namespaces or in multiple clusters. And you can see here, this is an application, for example, that's running in 2 different clusters and 3 different namespaces. And all 3 instances are unhealthy. And 1 instance was updated in the last 15 minutes. Someone rolled out a new change to the configuration. And I can take something specific and I can just drill down into the details. So here I'm drilling down in one of my clusters into Prometheus. I can see the CPU and memory. I can jump between different clusters. I can see the pods that are running. I can fetch logs from the pod. And I can see that data on exactly what's going on here with Prometheus. If there were alerts firing, I would see the alerts here. I can see the YAML. And then the other thing that we do that's really unique is we give a timeline of all the alerts that fired. And this is like Alert Manager on steroids. And here are all the alerts that I've fired. And I can filter and look at a specific namespace. I can look at a specific cluster. All my clusters we group. So here's like a Kubernetes job failed to complete 1,980 times, but it's just one row. We do the grouping. Of course, you can drill down to any specific instance. And the other thing that we do that's unique is we let you correlate changes with incidents. So most incidents are actually caused. There's some studies on this. Most incidents are caused by bad deployments that people rolled out or by changes they made in the environment. And you can see any change, like if someone changed the ingress and modified something and then something stopped working, you'd be able to see here, we pull in the diff and you don't need to configure a single thing in CI/CD because we just listen to the API server. So we get everything. Even if someone goes into the cluster and they make a manual change, we see it. And this is the SaaS platform, and it has stuff that's part of traditional observability, right? Like seeing the alerts and being able to investigate. And of course, here too, being able to like look at a specific alert and then drill down to details on here. I can like drill down to details, and then here too, we gather all the data that's relevant, like gathering in the logs if a pod crashed. We do that evidence collection so you see what's relevant. And then we have stuff in here that I guess you wouldn't put in a normal observability tool, but really makes sense from that platform engineering point of view. Like you're running an application on 2 different clusters. What's the diff between those 2 clusters? Right? So we have stuff that wouldn't necessarily normally be part of an observability offering. But if you look at everything platform engineers need to succeed with Kubernetes, then it's a very, very often requested feature. And I touched a little bit on the cost, but we also look at like where the CPU requests, where the memory requests, we solve those problems and tell you based on historical data what they should be. So that's what we do in a nutshell. And of course, there's lots more here, but that's the core functionality, and that's why we built Robusta.
Oh, really cool. I quite like this correlation feature that you mentioned and how it connects the changes made to the issues. I think that's really cool and very, very helpful with troubleshooting. Yeah, great job with that.
One of the interesting things is that actually many people who use Robusta already have an observability solution, whether they're using Grafana dashboards, whether they're using Datadog or Dynatrace or New Relic. Many people with Robusta actually already have an observability solution. And it's great for when you want to really drill down to the fine details, but it doesn't give you that first triage, it doesn't give you that first response, and it doesn't enable that developer self-service troubleshooting. So it's interesting how we have places where we use just Robusta and we're the all-in-one solution, and we do that really well. But we also have places where we're complementing other tools, and there still is a need for something that kind of gives you that first single pane of glass to triage issues and to determine what's going on. And then you jump out to other tools 10 or 20% of the time when it's necessary.
Mm-hmm. Yeah, really cool. And, that comes to mind that, Robusta kind of blurs the line between observability and incident management. It seems to do observability really well, and then also packs quite a bit of incident management features in it. Any thoughts on that? How do you see Robusta? Does it serve incident management? Did you intentionally design features into Robusta for incident management itself?
We did. There's an intentional decision there. I'll start with the decision. The decision is we will build the platform that every platform engineer needs, and we will blur the lines with other solutions when it's appropriate, but we will give platform engineers the best solution that they need and the best solution that their developers need to do self-service troubleshooting. And now when you look at that, let's go back for a second to the open source offering, right? We're looking at the open source offering. A very common thing that we hear is, okay, I have an alert like this, and I want to route this alert to different developers depending on the namespace. So send this to different Slack channel, to different MS Teams channel, depending on like which namespace this occurred in, because different developers are responsible for different namespaces. And as a platform engineer, I'm responsible for like the infrastructure namespace or the monitoring namespace. So like here's a feature in the open source where we have in here like rel alerts by namespace. And you can, in the open source, just route your Prometheus alerts and other alerts to different namespaces, to different Slack channels, depending on the namespace they originate in. And you could do it by labels and by annotations. You could even take like the names, you could take like a label or an annotation on the Kubernetes deployment, and then use that to dynamically determine like which Slack channel to send it to, right? So those are very much kind of incident management or like alert routing features, right? It's not quite observability. It's more the type of stuff you might even do sometimes with PagerDuty, like or OpsGenie, right? It's an incident management tool. And we integrate with OpsGenie, we integrate with PagerDuty, right? We're not trying to do everything they do, but this specific feature makes a lot of sense because platform engineers need it in our context. And we said, okay, if people need it, and there's a real need here, and this is what platform engineers want from the Robusta open source, we will give it, even though it's blending boundaries and blending categories a little bit. And then the other category that we also blend a little bit is the category of like multi-cluster management, right? So we don't do multi-cluster management for like managing all your clusters, but we will give you the observability aspects of that, right? So you can see all your clusters in one place and then see what's going on in each one and drill down to resources for the observability angle.
Mm-hmm. Yeah. So is there something like Runbook? I think I might have seen that on your website, Runbooks mentioned, or I saw just now in the docs or the help center that you showed playbooks. So is that what you covered as well just now, or is that different from what you just spoke about?
So let me show it to you. The way that this works under the hood and how you can extend this yourself is we just have YAML rules. So if you think of that alert, you go back up to this alert, which has here a Prometheus alert that has the pod logs inside of it, then this is just powered by these 5 lines of YAML. It's a trigger action language, like kind of like Zapier for DevOps. If this, then that. So you can say here, when there's a Prometheus alert, that's name is kubepod crash looping, then pull in the docs. And how does it know which pod to get the docs from? It uses the metadata on the alert itself. You can do all sorts of other stuff. So we actually have a library of dozens, maybe even 100 already, different actions like this. And we call these playbook actions. And you can go, for example, and you can say, go when there's an issue on the node, like go run a bash command on the node and pull in the data and put it in the other. Or go fetch a graph from Prometheus and render a graph of like the CPU or the memory or the disk usage, right? Or you can say, go, like here's a really complex example. Go, like I have a Java application that's misbehaving or has high memory. Now go and run JMap or JStack and grab like a heap dump or a stack trace based on that, right? And that's just the same thing. Like you can put in these triggers and actions. Actually, a very cool example that Vikas Yadav, who was up until very recently an SRE at LinkedIn, he actually has a very cool example he posted recently where he's showing how you can use Robusta to like find a Java application or Python application that's about to get out of memory killed. It's like really close to being out of memory killed because it has a memory leak. And right before it happens, you run over to it and use these run books to grab a memory dump of that and then to see why it's happening. And that's like really cool. But again, it's about that like responsibility model, and you get an alert. Well, how do you actually go and troubleshoot the alert right away and fix it with the data you need, and not say whose responsibility is it or there's missing data? How do you really get down that mean time to response? Well, you have to make sure that in that Slack message or in that Microsoft Teams message you're getting, all the data you need is actually there. And that's one thing we really help with.
Mm-hmm. Yeah, and I love the automation and the examples. I think the possibilities are quite endless. And if is someone who likes to automate operations and kind of build stuff, build processes that you can reuse, I think Robusta is really great for that. Really cool. Yeah, so I wanted to next move to talking a bit about cost reduction and how Robusta approaches that. And you mentioned it numerous times as well already, but if you could just directly address it for us now, and maybe with an example, a hypothetical example maybe, or if you have something to show, that could be great as well. But how does Robusta help with cost reduction?
Okay, so to get costs under control in Robusta, and I don't want to speak about Robusta, actually. I want to focus, I'll say a word at the end about what we do in our open source offering here, but I want to really focus on whatever tools you use. It doesn't matter, because like for many people, 2022 and 2023 have been a bit of a hard year in terms of companies' financial situations. Everyone has a mandate to cut costs, and people really care more about spend. So whatever tools you use, it doesn't matter. What I'm going to describe, you can do it by opening up Grafana dashboard and doing it manually. You can do it by running like kubectl top and like checking it 3 times a day and figuring out the numbers. You can do it however you want. You can do it with Datadog, you can do it with Dynatrace. The tooling does not matter. If you want to get Kubernetes costs under control, there are only 2 numbers that matter that you have to get right. And that's your CPU request and your memory request. You have to get those 2 numbers right, because those 2 numbers are the basis of everything. And to explain that, let's say you have a pod. Let's say you run 10 pods, and each one has a CPU request of 2 CPUs. So that's 20 CPUs total. The Kubernetes, if you're autoscaling, the Kubernetes autoscaler will make sure that you have 20 CPUs in your cluster. Your pods might not be using them. Your pods might be using half a CPU each. Your pods might be using no CPUs. It doesn't matter. The cluster autoscaler will go, and it will make sure that you have 20 CPUs in your cluster no matter what. And if you're not auto-scaling and you have 10 CPUs in your cluster, then half those pods will be in pending state and they will not be able to run. So how much you're paying for is only influenced by 2 numbers, CPU requests and memory requests, right? And that will determine how many nodes you have. And it's not impacted by what your pods actually go and do. Those pods could be burning CPU, they could be doing nothing, it doesn't matter. If you get those CPU requests wrong and you put them too high, then Kubernetes is going to go and it's going to allocate all these resources that you don't need, and you will pay for it. And if you put those CPU requests too low, then you won't pay too much, but now your applications will be resource starved. And you might be thinking, okay, well, Natan, what does the actual usage have to do with it? What's the relationship with utilization, right? Well, you want those requests to actually match like what they need, and then you'll have good utilization. So like if you set your CPU request to be like 2 CPUs and your pods are actually using 0.1 CPUs, then you're going to have really low utilization. So you'll have a cluster that has all those 20 CPUs allocated. And when you look at utilization, then you're going to have 10% utilization. So you can use utilization to check, am I doing a good job or a bad job? But to actually make the difference and to get 80% utilization, or to get utilization where you need it to be, there are only 2 levers that you can pull. And those are changing the CPU requests and changing the memory requests. So all of controlling spend on Kubernetes is about those 2 numbers. And the way to determine those 2 numbers is to look at the historical data, look back 2 weeks in Prometheus data, in Grafana, in Dynatrace, in Datadog. I don't care where you do it. Run the kubectl top command 3 times a day and do it manually for all I can. Write it down on a piece of paper and give it to your friend and ask him to crunch the numbers with a calculator. It doesn't matter how you do it, but get those numbers right. And what we do, I'll say a word also about HBA and our auto-scaling. like if you want to do horizontal autoscaling, you also have to have these numbers right. Like you can't autoscaler. Like when you autoscale, you're adding on, like think of it as you're taking a box and you're cloning more boxes, right? But you still want to know what size that box should be. And if you use the VPA, then there are other challenges there. In theory, you could say, I'm going to use the vertical path autoscaler, the VPA, and then I don't have to determine these numbers. In practice, organizations don't do that because there are some challenges around it. So most organizations that we speak to that use the VPA do not use the VPA in that way. There are some challenges there. So you have to get these numbers right. You have to get the CPU request and the memory request right. And we wrote an open source tool in Robusta that just does that for you. So the way it works is you run this, don't install anything in your cluster. You don't need to install a single thing.
Is the tool name Robusta KRR?
This is Robusta, github.com/robusta-dev/KRR.
Okay.
It's a standalone tool that you run on your local machine, and it just uses your, like if you can run kubectl get pods, or if you can run kubectl port forward, that's what this does. And it port forwards, so it connects to your Prometheus running in your cluster, and it does some queries, and speaks to the API server, and for every single workload in your cluster, it tells you what should be your CPU request and what should be your memory request. And it just bases that on the historical data. And we have details here on the exact algorithm and how it works. So we have details down here on the algorithm and the metrics we use. And you can, of course, customize the parameters. And if you use the Robusta, the other Robusta open source I mentioned before, right? The one that I showed you over here, if you use this, then there's actually an ability so you can set up a scan. So it'll scan once a week on a schedule, and then it'll send it to you in Slack. So here, like this handles, this project kind of takes Prometheus and takes all this data in your cluster and connects to Slack and MS Teams and other locations. And you does these run books and stuff. So we, of course, integrate the KR recommendations. You can get like a weekly Slack report on where you need to update your requests and limits. And then if you use the Robusta SaaS platform, then of course we have a screen here that shows that to you as well. And it's all powered by the same open source project.
Awesome. Wow, really cool. I love how you walk us through each of the examples you talk about and like show us what it looks like in action. That's really cool how you did it all through our conversation. We've almost come to the end of our talk today, Natan. With just a last question for you about just your thoughts on the road ahead for the space of observability and maybe even Robusta itself. What do you see down on the horizon? What excites you the most as you think ahead for the next year or two?
So 80 to 90% what we will do will be around stuff that really solves problems that platform engineers have today that we know about, and we know they're today also. Like if you think about, okay, how does a platform engineer define alerts, and then that developers opt into certain alerts or customize other alerts? What does a platform engineering first solution look like for that? What does a platform engineering first solution look like for dashboards or for graphs, right? Where you set that up. And we have a lot of stuff right now that's almost ready for release, actually. And we're looking for, and even in closed beta with some testers. And if anyone's interested, reach out to me. But we have some stuff there in closed beta that is really cool around those areas. So what does a platform engineering first solution look like? And then I'll touch on that 10 to 20%. There's been this big shift in the past year. Something new is possible that wasn't new previously around LLMs and AI. And this is an area that you have to be very, very cautious with, because you don't want to send your data, your company data, of course, and enterprises especially don't want to send their company data to OpenAI. But there are already some very good solutions for that. With Azure OpenAI, where it runs in a dedicated Azure environment, and now with Llama 2 from Meta or Facebook that can actually be self-hosted. There's some very interesting things around there that are making the privacy concerns go away. And we have a closed beta right now that's only open to a very small number of customers, but where we take LLMs and we feed in easily your observability data, and we do some very, very cool stuff there. And I don't think I've ever discussed this publicly yet before. So this is the first time I'm mentioning it. But
awesome.
We have some stuff here that's built, and it's built for enterprise first, and it's built with this platform engineering thinking about how do you not just give an AI solution, but how do you give a solution that empowers platform engineers to empower developers. So it means you're giving something that platform engineers can customize a little bit for their needs in their company that they can put their knowledge into. And how do you build a really great solution around there that's good for platform engineers who need to support many developers and that can actually enable developers to solve problems alone without pulling in the platform engineer? And that's really enterprise friendly with regard to the compliance and the regulatory side and data privacy. And if people are interested in that, please reach out to me, Natan Yellin on LinkedIn or AANTN on Twitter. We are going to be expanding the closed beta soon. So we are looking for more people who are interested in that. And that is 10% probably to 20% of what we're doing. But it's an area that if we can consistently get the level of results that we've been able to see so far in closed testing, then I think it's going to fundamentally change how a lot of people work and really enable some platform teams to enable developers to do some things alone that today they need to pull in the platform teams for. And at the same time, we're really empowering the platform teams and giving them something that they have full control over and that they can customize and can make even better. Because we're just a product, and the platform engineers are the people who are out there fighting the battle and doing stuff, and they have all the contacts more than we will ever have. And we really think, how do we empower them?
Mm-hmm. Wow, exciting. Do you see this launching sometime next year, or it's just too early to say at all?
Oh, we'll have this ready far before next year.
Oh, okay.
Talking about a much shorter time frame. We already have people who are taking this and trying this out in the real world. So it's very exciting. By the time this is live, I think we'll actually have so I don't know when things like this goes live, but we'll have some very maybe we'll even have some exciting stuff to announce.
Yeah, you should definitely come back and demo it for us when it launches. We'd love to see it.
Yep.
So yeah, almost at the end, last couple of questions to just get to know a bit about you, the other side. What would you choose as your alternate career path if not for your job in tech?
Full-time dad.
Full-time dad?
Full-time dad.
Oh, okay.
I got a little guy now. I got a little guy 3 months old, and
okay.
It's something I think about that, right? How do you balance being the CEO of a fast-growing venture-backed startup with lots of customers who we love, but who also require a lot of attention, of course, and we want to make them really, really happy. And at the same time, I also have a personal life, and I have a little guy. So if I would take a different alternative career path, I think I'd be a full-time dad and let my wife work full-time.
Wow, I love that you really seem to enjoy being a dad. Yeah, that's great. Congrats to you and the family. What is one productivity hack that you could share?
Let me think on that. Okay, yeah, if you're on a Mac, and let me just check it. I know it with my fingers, but I don't know it with my hands, like with my mouth. Okay, yeah. If you're on a Mac, let me show this to you actually. Every text bar on Mac OS, I don't know if you can see, but I've selected this up here. Every single text bar on Mac OS has Emacs shortcuts enabled. So I can press Control A and go to the beginning of the line, and I can press Control E and go to the end of the line. And I think I can do Alt F. No, I can't do Alt F. I think I can do Alt B to go back. Now that doesn't work. There's a different variation on that, but I can jump around in any line. Oh yeah, okay. So Alt Delete to backspace a whole word. There's actually Emacs shortcuts in like every text bar on Mac OS. And of course, these also work on the terminal. On the terminal, if you're using Bash by default, it's configured with Emacs style shortcuts.
Oh, really cool. I didn't know that. Just trying it out, it works. I should go check out the whole list. Yeah, we're out of time, but it was wonderful chatting with you, Natan, and thank you so much for joining us. I really hope you'll come back to talk about the next release for your product. Yeah, thank you so much for joining.
Yeah, thank you so much. It's been a pleasure, and I would just encourage people. We're building this platform for platform engineers, but we can do it because everyone comes to us and they speak to us and they tell us about their challenges. So if you have an interesting challenge, speak to me. We'd love to learn about it. So thank you very much for having me, and take care.
Yeah, my pleasure. And thank you to all of our viewers and listeners for tuning in. Go and check out Robusta, their website, if you like what you heard here, and tune in next week for another episode. Bye-bye.